Hello. Today I will be demonstrating how to submit Snakemake jobs to the Slurm cluster. So this is a topic that I got requested quite often, and this is something I do myself often as well, so I wanted to make a video out of this. So just a quick introduction to Slurm. On Google, you can search Slurm and you can find this website, and it's a job scheduler. So used in a lot of scientific research centers where they set up a high performance computing cluster, and people can submit their analyses to the cluster, where the compute nodes within the cluster runs the analyses and then reports back the results and stuff for you. So this video is assuming that you are already familiar with clusters and how they work, and you've used at least one of them. I'm going to demonstrate how to integrate Snakemake with Slurm. And for this demonstration, I am using a Google Cloud platform to set up the HPC Slurm cluster. You can, on Google Cloud platform, you can search this on the marketplace, and it's fairly easy to set up. The documentation's done quite well. So this is a very minimal sort of setup that I made, which I won't explain here. So here, I'm inside the cluster. So here I'm on one of the login nodes, and I set up two partitions for this particular cluster. Each of the partition, so P1 and P2, and each partition has two nodes. So if I do this, so I have 4 nodes in total. These are very small compute nodes, just created for this particular demonstration, so I didn't need a massive sort of cluster. I have Snakemake installed here. Just check the version is 6.15.3. This is a fairly old version because the cluster itself comes with Python 3.6.8, and if I just quickly show you the changelog. So as of recording this video, today is the 8th of May. So there was a recent sort of update, 7.6.2. This is the most up-to-date one as of today. I'm using a fairly old version. If I scroll down, it's this one. It's because from version 7, you need 3.7 Python to run it. So I didn't want to just go through the trouble of installing the higher version of Python for this demonstration. So I just installed the older one. Okay, so let's get started. So like always, just a very simple rule, no input. This is going to create an output, and then the wildcard is going to be num.text, and then let's just use a shell directive and just echo the wildcard inside the output. Okay, so I'm not submitting this job yet. I just want to demonstrate. Make cause 1, and then I will do output 1.text. Let's just get this, and I'm going to close the file explorer for now. If I run that, the job completes instantaneously. I'm just going to put a sleep command here, just so it sort of remains for a little while. So I can see in the output there's our output file. Okay. So now I'm going to let's build on this. So the way to submit this rule as a job into Slurm. So sbatch command is the command used for submitting jobs to Slurm. If I just do that. Let's just do sbatch help. You see, this is the command to submit jobs. I'm not going to go through the different commands for Slurm. This is something for you to find out yourself. This isn't a Slurm tutorial. So here I'm going to, so I ran the command as like this to generate that one text. I'm going to build on this. So instead of, to be a bit more informative in terms of Slurm, I'm going to change that as jobs. This isn't going to really change much in terms of functionality, but just to be more specific to Slurm. So now I'm going to actually add the cluster. So this parameter is the one that you would want to use if you want to submit to a cluster. So here I'm giving a text, which, because sbatch is the command that is used to submit jobs to the Slurm cluster, I'm going to type sbatch here, and I'm going to give it a bit more parameters for the sbatch command. So here I'm going to write partition, and then I'm going to do p1. So I just showed you earlier, we have two partitions. I'm going to submit my jobs to partition 1. So this parameter is the parameter for sbatch and not for Snakemake. You need to keep that in mind. And then here, a couple more. So CPUs per task. I'm going to do threads. I will explain what this is. You might guess what it is if I complete the remaining command. So here, mem, and then time, I'm going to say 1 day. And then let's do it. Let's do this for now. Okay, so now I want to make command 2. And 1 job. Okay, so here, if you've watched the previous video in terms of going over the resource functionality of Snakemake, in the shell directive, you would have seen me use the same variables. So here, sbatch will evaluate this cluster parameter will be evaluated. So when I'm submitting this job, I didn't specify number of threads, but 1 is the default, so this will be replaced as 1. And this, I didn't specify a default again, but mb already has a default, if I remember correctly. So that should be replaced to something else. So if I submit this, if I run that, oh, one moment. I need to, oh, I forgot a / here. So if I run this, resources does not has object. Okay, so there is no default evaluated. So here, another thing that I should have shown in the previous video is default resources, and then I'm going to do mem mb equals 100. If I didn't specify a resource, directive in the rule itself, that value is going to be used. So for instance, the resource that will be used by this rule will be 10, but if I didn't specify this, it will be 100. So that was just a demonstration, so I'm going to delete that. So let's submit this again and run. You see here, the job is being submitted. So I'm submitting one rule, and if I just have a look in the output file, I'm going to try submit to a different class partition. Let's try submitting this to partition 2. If it does run correctly, you should see the job has been submitted as job number, job ID of 3 or something, but the command isn't being shown. Sorry, my bad. So the job wasn't submitting because of just a very minor thing. So here, this end of string with the single quote shouldn't be in the new line, it should be up here. So if I submit that, and let's resubmit, and you see here submitted job 0 with a external job ID as 42. So if I do this, I think it's completed. So SACCT S account, and then the J option to specify which ID. It shows the job status. So as you see, it's completed, and Snakemake also sees that this has completed successfully. So if I look inside the file in the folder, let's refresh. You see the second file has been created and the output files are generated here. This is the default log files that is created by Snakemake, Slurm, sorry. So what you can also do is specify the path to the log files. So here what I usually do is do logs and then rules, wildcards, and then O. Just copy and paste this to get the error file. And if I do that, and let's create another file. If I run this, rules, so this is a typo, sorry. Should be rule. If I submit that again, the job has been submitted and it's completed. It's just taking some time to evaluate. So it's completed. I'll go over this as well. So the job did complete, but Snakemake evaluated it as it failed, despite the file being present. The output file is present because of the latency between the file systems, between the nodes. Okay, so if I just quickly show you on the logs, you see that the two log files has been created, the standard output log and the standard error log. So for the rule hello, and then the wildcard as 3. So one more thing that I will add here is the latency wait parameter. So the default is 5, but you see how if I look at the nodes, these nodes they share the file system, particularly the home in our case, they're sharing the file system, but there's some latency between when the node was analyzing here, when the node that accepts the job and ran this echo command completed in that node, and the file is visible in that node, but we're on a different node. We're on the login node, which there's some latency between the two, even though they're on the same file system. So what you can do is increase this number so that Snakemake waits a maximum of 30 seconds to check whether the files exist. So we do that. Let's give this another number and we can rerun this. So this hopefully should say that it completes. Maybe I should get rid of this sleep as well. I'll comment it out. Okay, so the job completed and it's waiting for 30 seconds maximum to check whether the desired output file has been created. And it detected it, and so Snakemake correctly evaluates this rule as being completed. So that's good. So let's increase this a bit. So let's do rule all and then input expand. Let's copy this so that we are creating 10 of these files. So now I'm going to increase the number of jobs to run at the same time. Let's do 4. Submit to partition 1 and default 10 megabytes, 1 threads each. The maximum runtime for the job should be 1 day. It's instantaneous, so I don't need to actually. I can have it something much lower, but I'm just going to leave it at that. Let's remove the specification of a particular output and just say we want to run this rule, because this rule is the first rule in the snake file. It will run this rule. Okay, let's one more thing I'm going to do is I'm going to reduce that to 5 so that because of the latency the jobs will fail. And I'm going to delete all of the output files. Delete the output files so that I need to make 10 outputs. Let's clear this, just and copy and paste and run. So there will be 4 jobs being submitted at the same time. At the time, you see 1, 2, 3, 4, and these should fail. Let's just wait for a moment. They are configuring, so the resources are being allocated to run those. I'm just going to pause the video for a bit to see and resume once the jobs have completed. Okay, so some of the jobs failed because of the file system latency. So as soon as one job failed, the remaining jobs, there were some jobs that were still remaining, waiting to be run, but those were halted, so they weren't submitted. So one other thing you could add, I'm not sure if I went over this parameter before, but you can add this option where even if one of the jobs failed, the remaining independent jobs just keeps on getting, you can specify it so that the remaining jobs can be submitted if they can. If the job isn't dependent on the job that failed, Snakemake will submit the remaining jobs. So that you can add, and the remaining jobs should be submitted even if one of them fails. I'm not sure if this is a problem with the older version of Snakemake, but I'm getting I'm getting another error. It's probably a bug that's been fixed in a newer version of the Snakemake, so this isn't something to worry about. So here I'm just going to just increase that back to 30 seconds and delete all of the outputs that have been generated. Sorry. Just going to delete that. And so that's empty, so I'm going to rerun. Let's also delete the logs directory as well. Delete all of that, and then submit. Let's increase that to 100 and run. So if I show you all of it, so here I'm specifying that I want to run 100 hello rule jobs. All of these will be submitted to the cluster. There will be 4 jobs that will be submitted at the time, because I specified 4 jobs. Each of them will be specified 1 core and 10 megabytes of memory, and they are specified to run for a maximum of 1 day. If it doesn't complete within 1 day, the job will be cancelled by Slurm. The log files will be generated under the logs directory, like I specified here. You see jobs are completing fine, and this is basically how you can submit jobs to the cluster. I'm not going to demonstrate it. I'm not going to actually submit it, but I'll show you one more thing. So I made a video about how you can use Singularity. So you can use Singularity containers to isolate your environment for the rule. So here, if I, in the snake file, if I do container, and then I did like path to a Singularity file like this, and then if I do use Singularity, the jobs will be submitted, the jobs will be run inside the container. If I have a file system parameter that I need to add, so for instance like this, I would need to data, something like this. So here basically you will be submitting the jobs like this, exec, and then data, and then the script, the job. So this will basically be added inside the running of the submitted job, so that the job will be run inside the container. So I won't be running it because I didn't install Singularity, but this is something that I do commonly, which is very useful. So hopefully that was useful. If you have any other requests like this, you can leave a comment, and thank you for watching.